Okay, so we went through most of the lecture last time, believe it or not. We've got just a little bit of lecture left today, so I'm going to do that real quick first, and then the rest of the time will be yours to do the pre-lab, which is a pre-activity, because it really doesn't count, but it will help you understand some stuff, and it's sort of cool. We're going to make esters or make smells like banana and that. Yes?
I thought we didn't have a lab.
There isn't a lab. It's not a lab. It's an activity. We have one more lab left, which is in Unit 12, which is DNA. But we're going to do a little activity. It won't count, but it'll help you sort of understand what's going on.
Do you need to turn it in?
No. So what we're going to do is I'm going to finish the lecture, and then your time will be to finish what's going on in the modeling that we were doing last time, and then just to look at the pre-activity questions for next time. We'll be making some fragrances, and you can sort of see what ones you would like to make by putting an alcohol and an acid together to make an ester. So you do need to be familiar with the different shapes and the different functional groups for the test. So, and then next time I'll hand you out your review, and then we'll spend a day on the review and then test, and on to the next chapter. So really fast, quick tests going on. The lecture is up there, so if you need to go back over last time's lecture, it is up on Canvas, and it is also on Teams. Okay, so the last part of this chapter basically deals with the focus on health and medicine that has to do with organics. The fat-soluble vitamins that we have are A, D, E, and K. These are fat-soluble because they are long and they don't have a polar side. Okay? They have many CC and CH bonds, but very few functional groups attached to them. A water-soluble vitamin will dissolve in water because it has many polar bonds. We do need a small amount of these for normal cell function. A lot of people go overboard with some of them and end up with too much, and that is also toxic to our bodies. So we need some, but if you eat too much, like I had a cousin that ate carrots, and that's all she ate. She just got on one of these fad diets, and all she ate was carrots, and she actually did turn orange, just like carrots. And she got the belly like the Ethiopians, and it was really sort of gross. She's straightened out and now is eating semi-normally, but if you get on a fad where you just eat one's food, then you can cause a lot of problems to your body. You can see that each of these vitamins has to do with a specific thing. But if you have a ton of vitamin K, for instance, in your system, you can actually cause heart problems. So depending on, moderation in all things, right? Okay, going forward, maybe. Come on. Vitamin A and other fat-soluble vitamins are readily stored in the liver and fatty tissue. Vitamin C and other water-soluble vitamins are stored in the gastric juices of the stomach and in the blood, and these vitamins are readily excreted in the urine. So we have to constantly be taking in things that are water-soluble because they go right through our system. The fat-soluble vitamins tend to stick around. So they're harder to get rid of once we've got them into our body. So taking on too much of them can be a hard thing. For instance, if you have too much vitamin A, K, D, they sit in your liver and they get what's called a fatty liver, which is a precursor to cirrhosis, which is hardening of the liver, which then causes liver failure or liver cancer. Okay. Vitamin A is retinol, is used, helps with the vision receptors in the eye. It also helps maintain the health of mucous membranes and skin. This is what vitamin A looks like, and you can see it has a ring in it. This is not an aromatic ring, and remember, an aromatic ring has to have every other one a double bond, and it's only a 6-member ring. That's a benzene ring. This is not aromatic, so if she asks you if it was aromatic, you'd say no. Okay? It does have every other bond, a double bond, in the chain that comes off of it, so don't get that mixed up. Okay? It does have an OH at the end, but it is a large molecule, so it is not polar, and therefore cannot be dissolved in water, but it has to be dissolved in fats. Vitamin C is water soluble. Can you tell what the difference is with vitamin C versus vitamin A? It's just a small ring, and look at how many oxygens it has. It has a lot of polar sites, and it has several that are OHs, right? And because it has several that are OHs, it can form hydrogen bonds. Vitamin C is very important for collagen, which is a connective tissue. As you get older, you lose a lot of the collagen. Deficiency in it causes scurvy, a condition that used to afflict sailors because they had no access to fresh fruit at sea. It does have very many polar bonds, and therefore it makes it water soluble, like I was telling you. And it does come from fresh fruits. That's it. So, are these aromatic? Yes, they're aromatic because every other bond is a double bond, and it's in a group of 6. So both of these are aromatic. Dad, where did I come from? Read this. Okay, we've got the organic division, which we've just begun, and we just came out of the inorganic division. Okay, so as you go to study for this, I told you last time that these kits are going to be your friend. You've got to get into your head what the molecules look like in a 3D sense. And you've got to get into your head those different functional groups. You've got to be able to identify a functional group. For instance, this is a what? The double-bound oxygen. By itself, it's a carbonyl. Because it's hooked to a nitrogen, that makes it a amide. An amide. Okay? If it was just the nitrogen by itself and there was no double-bound oxygen, that would make it an amine. So amide and amine have to do with nitrogen. Just remember, nitrogen's in the column that arsenic's in. That makes it amine. Okay? That's how I remember it. Okay? If it was just a double-bound oxygen in the middle of a chain, that would be a ketone. Okay? If it was on the end of a chain, it's an aldehyde. If it had an OH, it's an acid. So you just need to be able to recognize these. If you don't remember them, this is something I would put on my card, because she will have you identify the different things. Okay? You need to be able to identify polar versus nonpolar, organic versus inorganic. Okay? I will have, like I said, I'll have a review for you next time, but I want you to make sure that you do that, finish that activity that we started last time with building those molecules, looking at the shapes, getting into your head, okay, that's tetrahedral, this is trigonal planar, this is bent, this is, all those different shapes that we talked about last time, because you'll need to know that. She'll take a molecule like this and say, okay, what shape is this carbon right here? And it would be what? Has 3 things attached to it. Every time it has 3 things, think tri. So it's trigonal planar, because the double bond forces it into a flat plane. If it had an unshared pair of electrons like this, and it pointed to the nitrogen, what shape would that be in? Trigonal pyramidal, because that unshared pair of electrons pulls it out of the plane. Okay, so it's still trigonal or trigonal pyramidal. So tricycle 3. Okay. Trying to see if those are the only shapes on those two molecules. Anytime you have 4 things attached, It's going to be tetrahedral. And what did I tell you about the 109.5?
That she can say approximately or about.
And that would be for anything that would be less than like 107 or 105, which is the band or the trigonal planar, or trigonal pyramidal. Trigonal planar is what? What's the angle on trigonal planar? Take a circle, divide it in 3. So a circle is 360. Dividing it in 3 is 120. So that was a flat one. So you did the trigonal pyramidal when you told me 107. Okay, that's the trigonal pyramidal, and that's the one that she will say approximately 109.5. Okay, and the bent she'll say approximately or about 109.5. Okay? All right. Any other questions? Okay, time is yours to work on what you need to. Look at the lab for next time. Again, I gave you the lab, the pre-lab part of it. It's a pre-activity, sorry, we can't call it a lab. It's a pre-activity. We'll give you a chance to sort of put things together and look at what's going on there, okay? All right, I'm here if you need me.